The overall goal of this methodology is the conversion of trans-ferulic acid to vanillin by heterogeneous catalysis using the porous coordination polymer HKUST-1. The essential step in the catalytic process is the generation of unsaturated metal sites in HKUST-1.
This method can help answer key questions in the heterogeneous catalysis field, such as in the production of vanillin, which is one of the most widely employed flavoring agents in the world.
The main advantage of this technique is that we provide an experimental protocol to catalytically convert ferulic acid to vanillin under mild oxidation conditions.
The implications of this technique extend toward the use of porous coordination polymers as catalysts. Generally, individuals new to this method will struggle because the activation of the HKUST-1 material is fundamental.
Demonstrating the procedure will be Rebeca Yépez, a grad student from my laboratory.
To characterize the crystallinity of the catalyst, collect a powder X-ray diffraction pattern of a 0.1 gram sample of HKUST-1 as described in the text protocol. Record a powder X-ray diffraction pattern from 5 degrees to 60 degrees in 0.02 degree steps and 1 second counting time. Then, perform dissolvation of HKUST-1 by first weighing 0.05 grams of the catalyst.